Good morning, hello! How are y'all doing today? Sound looks like it's kind of good. Should be good to go. What do we have going on today? Yesterday, sort of like going into this very slow back and forth with our community member. So, SOS said, our U32's length will be 1, but the entity's length should be 2. Okay, so they suggested create an entity with a component, then remove the entity, then try and query again. So that's what we're gonna do. Okay, so back on to test here. So we're in. Actually, it's part of this entire entities thing, right? So it's source entities query. So we had this previous one where we test with no components. Let's try this again. So we're gonna do test function. This is gonna be query for query after deleting that entity. Okay, so the standard normal thing. No autocomplete?
Yo, what's going
on? Okay, so there we go. We're gonna create we're gonna create entities. We're going to create. Let's create 2 entities for this. So that means we're gonna register a component. Okay. The component. Let's just do this U32 again. Doesn't really matter. Then we're going to create an entity just like we have right here. Okay, with a component, and we'll just say year 10. Then let's create another entity, and this one will just have a completely different component, let's say. It'll be 20. Okay. Then let's delete one of the entities. So entities dot. So delete entity by ID. We're gonna delete ID 1, so it's the second one. So only the 10 should exist. Then we should be able to do our query. So we should query for everything that has these components, and then it should work sort of the way we expect it to.
Yo, what's going
on? Bullfristad, hello. Don't think I need to do it mute query like that. I think what I can do is I think I can do this. So we're going to do a query new pass of the entities. Then just do this with with component U32 and then run. Okay, that will give us this. So here we're going to have the indexes, the query indexes, and then the other one is the actual like results. Oh, you like my hair today? Thank you. It's It's slowly growing out from my last haircut, so it's sort of random whether or not it handles whatever I want it to do. But thank you. Okay, so here's our query results. That's what we want to see there. And then we want to see that, first of all, these should be the same length as each other. So let's try that. Let's do sort of equal, and we're gonna have query indexes. And then also the query results. That length. Those should be the same. So if I run this, we should be the same. Man, moving is super hectic. Paid for my first rent bill, got an electricity contract, so you got electricity for when you move. Going to IKEA. Is it IKEA or IKEA? Or IKEA? I don't know. I've heard it pronounced different ways. For some furniture and a router, moving in on Saturday. First one, IKEA. Okay, good to know. Well, congratulations on getting a place. I know that can take a little bit of time. Wait, query after deleting an entity. Oh, well, then at the end of this, we return it okay. Didn't take that long, a few months. Most people wait a few years. Oh, wow. That is a long time. Okay, so these two vectors are the same size. So that is correct. We wanted that to happen. So what's next? I want to make sure that we deleted one, so we also need to make sure that their length is 1. So let's do another assert. So assert equal that query indexes.length is 1. Let's do query results on this one. Okay, so that's still fine. It still only found that one thing. Well, let's see. Okay, so we found the right one. So let's, the first index should be 0. So we can also test that. So assert equal that query indexes should be 0. So that is correct. It found the right one. Then after that we could check the other one because there's only one thing. Guess there's only one component. Oh, I think it's query results of 0. I think that's what we need to be. Yeah, but that's still, there's only one entity's worth of component in there. We can then grab that out and actually verify that it is the correct thing. So then, oh, you got your new laptop too? Oh man, moving to a new place, got a new laptop. Sounds like a good time. Let's see. So then I guess the last thing is, look at what it's trying to do here. It's thinking that we want to check the contents of what we got, which is kind of what we want to do. So it's going to be assert equal. You got arch onto it, just one issue that was causing it to be completely unusable. Working internet. What was it? Is it something? Is it sillier than just like the wrong driver? Is it was it something like you had to plug it in, like you had to unplug and replug the? Oh, network card in Linux isn't supported. Yeah, that I remember those days. Yeah, that's a thing. It's like one of the reasons why Ubuntu has become more popular as a desktop machine is because they've been working with all the manufacturers of like laptops and notebooks and PCs and trying to get like drivers for all their stuff. Okay, so query results. So query results, the first one, and then the first one of that, borrow it. So we can't do this all in one go. That's just unfortunate. We can't do that. You just love Pac-Man and AUR too much? Yeah, I totally understand. I've tried Arch a few times. I never really got into it. I don't know. If I had discovered it when I was a sysadmin, I probably would have like dove in deep enough into it for it to like catch. But I don't know. For some reason, I just never really, fell for it. I was a Red Hat person, so I did a lot of Fedora, a lot of Red Hat Enterprise, some CentOS, CentOS? Yeah, CentOS. Before Red Hat acquired them. I know they're getting rid of it, which is sad. Let's see. So I need to get the first one out. So I don't know if it's the first thing. I don't know if it's this entire thing here. It's like the borrowed first. Is it borrow that we need to do the first thing? I think so, because we're getting in here. So if I do that, okay, then we have this ref-dyn any. Then we can downcast it. So that first U32, borrowed first U32, downcast ref to U32, okay? Then we can assert equal that the first U32, but destructured, is 10. Wow, I think Copilot's gotten better at figuring out what I want to do. All right, so I'm still getting this. I'm still getting that that fine. So I don't really. I should. All right. I will message him again after this one, but let's go ahead and commit this up because it seems to be working just fine for us. So let's see. So trying to recreate query problem. And I'll go ahead and push that up. See, right now I just got Windows. Once you move, you're going to spend time with Python. You think it's about time as a software developer you learn Python. It's a great language. Yeah, Python is a good language. I never got so far into it that I learned too many of like the negative side of stuff, and I stopped using it before like 3 became a really big thing. So I mean that dates how long ago I used Python. But I agree, I have fond memories of it. And it's one of those things where like if I felt I needed a backend script for something that could run almost anywhere, I would probably just choose Python. How do you keep dust off of glass screens? I don't know any good ways to do that. The only ways I know is to then like just wipe it off and clean it after it's got dust on it. But I don't know. I'm not a huge screen protector person. I used to use them, but then like they would get dirty and like they would cover the screen, and like I would feel that I'm just not getting the value out of my device, like because the screen wasn't looking as good anymore. So I just stopped using them. All right, that's up there. Let's dive back into the Rust library. So your laptop has a glass screen similar to a Mac. Yeah, so it's probably just wipe it down every day. Get like a really soft tech, like a what are they called? Like a tech wipe or something. I just have like a pile of them that in my closet that I just use every once in a while. Yeah, microfiber cloth. Okay. Borrow mute. Now the big thing is this is like the same as borrow, essentially, except mutable. Except, oh, except I think. Except you can get a mutable reference instead of just a direct. But everything else is exactly the same. Medium Q, hello and good morning. Use Touch lens and screen cleaning wipes. Yeah. And I think I at one point in time found this spray that I could use for like cleaning, but it was a long time ago. Also safe for the VR headset lenses. Oh, that's nice. Yeah, those are. Yeah, I've just been leaving mine out and it's pretty dusty. Okay, so basically then we just have our required types or required methods. So mutably borrows from an owned value. So basically have to be careful with some of the sprays. They could damage the Mac screens and their sensitive type of screens. I know, and the screens keep on changing. So like something that was good years ago may no longer be good anymore. Just and vice versa, right? Like it could be that the ones that are good for now don't work on older screens. So it's not fun. So yeah, if we have just something that we want to borrow, this is like showing that it has to implement borrow mute for an i32. But the entire idea is like, hey, if we have, let's actually jump in here. Here's this borrow trait. Let's say we have this like wrapped string that we have, and we implement borrow for that. So we actually get this, like a stir that works for this thing that allows us to search for this wrap string using something else completely. The big sort of like the big deal here is that whatever we get out of the borrow must implement the same things that like this, you know, this does as the key for hashing and other stuff. So in important things. But that being said, it's let's see. Besides that, it's the same thing. So let's see. Get a mutable reference to the like object being borrowed. Like kind of weird. It's really going to be just the same as that one found in here. And then we have our implementers, which is a very small list. Look at that. We have string, vec, and box. And borrow mute. But yeah, string, vector, and box. All right. A slice. A dynamically sized view into a contiguous sequence, T. Contiguous here means that elements are laid out so that every element is the same distance from its neighbors. Okay, so slices are a view into a block of memory represented as a pointer and a length. Right, okay. So basically like in memory, a slice is just really like a pointer to here's where they are in memory, here's how long I want it to be. So for example, this is giving me the slice of the entire thing. Slices are either mutable or shared. The shared slice is obviously a reference, where the mutable one is a mutable reference, where T represents the element type. For example, you can mutate the block of memory that a mutable slice points to. So yeah, we can change it like that. As slices store the length of the sequence they refer to, they have twice the size of pointers to sized types. One thing that Windows does very well is make it easy for the consumer. I would say that like Windows and Mac both are like, that's their primary objective really, is like to try to make it easy for the consumer. And Linux is like just a good operating system, but yeah, and then just slowly steal everything from Windows and Mac. Well, Windows and Mac steal from each other too. It's a fun world we live in now. Okay, so this is interesting. Slices have twice the size of pointers to size types. So okay, we can do this with like a size of thing. This could be interesting. Let's do primitive slice .rs. So if we have this just array, let's do like the one through like the 1, 2, 3, 4, 5 thing. Ah, here, X, 1, 2, 3. Then I want to get the size of this thing. And I guess it's really going to be, so I can debug. It's interesting. Oh, okay. Standard memory size of this, like U8. Interesting. Okay, so I can do, let's do size of, it's equal to, okay, so we're going to do this size of from memory. And we're going to give it something. So let's just give it X. Let's find out how big X is by itself. And really, I want a reference to X. What are you upset about? This function takes 0 arguments, but 1 was supplied. Okay, so that's not how you do it. Oh, so a reference to a U8. That's all I can see. Oh, I see. So, oh, okay. Can I do that? So size of, I want, come on. A U30, oh, these are I32s. So I32s, 5 of them. 1, 2, 3, 4, 5. So give me that. Let's take a look at what this is. You hate using closed source software, but until your network card is supported, you gotta do it. I mean, yeah, I've sort of like, I don't really care as much anymore. All right, so size of this array, so an I32, an array of 5 I32s is 20. So if I want to do, so this is going to be size of just like the thing. So size of thing, let's say. Now, if I want to do that size of slice equals, let's do a, I think it's the same thing here. So like 5. So we have slice and size of thing. Well, that's not correct. So that's not double the size. How do you do this? It's okay. So size of memory of U8. Oh, because that's a single U8. One thing you're looking forward to, though, you're finally going to be able to Arch on your main PC. What was holding you back previously was games that required EAC to play, which is an anti-cheat that wasn't Linux supported, but they've recently announced there will be full support for it on Windows. Wait, on Linux. Okay, that was going to say, I was like, doesn't it already support Windows? But yeah, okay, that'll be cool. And Steam runs on Linux now, and Proton, when I was on Ubuntu, was really good. It supported a majority of games right out of the box. Okay, so is that really what I can get? How I can get the size of this? Like, is there a better way for me to find like how big something is? Can I do something like I can't find the size of that thing, like this. Which is unfortunate. Yeah. So, I don't know. Am I just doing this wrong? Is my reference not supposed to be there? Is it supposed to be here? There we go. Okay. So the size of the slice is 40. So 5 of these items. And so if we switch these to like, I don't know, 3 each. Does that change it also? It is. It does. Okay. So as we can see, the slice gives us a reference to the thing inside of it. Whereas this gives us a the actual just the thing itself, which is double the size in memory. So that is something to be aware of. So you are, in this case, you are indeed 12. And you are indeed 24. So the memory of a slice is always double the memory of the actual thing itself. And then just implementors. I don't think that they have, I guess like there's a slice module for like what the slices are, but this is like the important thing to remember is that slices are not cheap. And so the larger of an array that you have, the more careful you have to be because you can get out of memory pretty easily, but they're also really nice because I can get just like a copy of this. So we know that this is a size 20. So size 20 in memory. And then we also know that if we do let copy or slice of x, and it's going to be, I think, x dot dot like that. So it's everything. That will be size 40 in memory. But it is the same things. And so that may not feel right, like it's why it's just reference to the things, but it's they're as long as it's like the primitive stuff, it's gonna be bigger. So that's good to know. Convert as mute. So we did as ref before, and actually it looks like we've already done this one. Let's just double check that we got all the required methods. Yeah, we did. We did as ref, we did the borrow mute. Okay, it looks like I just had some of these in here multiple times. Format debug. Have we already done this one? for our methods, this FMT, and yep, yes, we did. Kind of want to give it an icon because everything else is getting icons. Even though that one is impossible to see. Okay. Default. Default. We haven't done this one yet. I know there's a way to search for traits only if I wanted to, but I'm not gonna worry about it too much. Okay, so default trait. It's obviously a trait for giving a default value to something. It is derivable, I know that. So, can be derived. To reduce like our own code base. So like manual code. But if we do that, everything inside of that, like all the members, must also implement default. So. Okay. Now, default does not give us the ability to like default in functions. This is only like structs and enums. I don't know if it's even enums. I think you can do it with an enum too, right? We should find out if we can. So yeah, if we have this like struct sum options, this foo I32, the bar I32, if we derive the default, then they're gonna get zeros. So like 0 is the default for all of these things. So here we can see that sum options equals default. So we could just do this default, or you can also use the method default on it. So let's actually implement that. This is the trait default. So let's create like a location. So we're gonna have a struct location, which is gonna have an X, which is, let's just do like an F32, and a Y, which is an F32. So if I derive, sure, debug and default, then what I can do here is let player location is equal to location default, like that. So now I can it just exposes this method for me. And then if we debug our player location, and we run this, we should see now that we've got 0.0 and 0.0. KO2 fan, hello. How are you doing today? So yeah, it basically just gives us zeros. So these default will be 0.0. Obviously, I32s will be 0, U32s will be 0. That's like the standard default. Now it looks like you can also just run default like this. and like tell it to give you something. And that apparently also works. Polly and Secure, hello, and you're heading to sleep. So thanks for stopping by, and also have a good sleep. So apparently I can just do this too. Let's double check that. Come on. So I can also say that you are a location, and so I want you to be a default. So this should also work. And there we go. It does indeed. So let's see. So the big thing here, we can also do that. The trait, the default trait exposes a default method that will basically create construct, I guess. Construct the object with default values. We can also use the default. I guess it's the default method it's like the default static method. So the default static method on the default struct get the same thing only if the type is known when it runs. So if I have like a function that returns something, then it can run that like sort of like default. And that could be a way to sort of have a constructor function that lives outside of a struct. I don't know if that's a good idea or not, but it's certainly possible for you to use. Now, if we want to implement it ourselves, so let's say we have another thing here. So let's create not a location. Let's do a velocity, let's say. So we have a struct velocity, which also is going to be like an X, F32, and a Y is an F32. So normally we could just derive default on this as well. But let's say we don't want to. And right now, if I just add into, let's create a, one more struct, like a player or entity. We'll do an entity. So an entity has a location and an entity has a velocity. And we're going to derive debug and default here. Now it's going to yell at us saying, hey, I can't do this because our velocity must be implement default. Because otherwise, when I implement default here, it's going to try to implement the default of velocity, which doesn't have one. So what do we do? So we're going to implement this manually. So impl default for velocity, implement the missing members. This just default function. That's the one that was exposed for us. And then we can just set what the. Thank you, Rest Analyzer, for barfing all over my code. I guess it didn't barf over my code. It's just my logs. How about you just go ahead and restart? Okay, so we have our function default. So then here's it's just a constructor. It's just a standard constructor. We're gonna say, well, it's gonna try to like do the default, and we see it's running the static method on default for each of the members of here, which will work because F32 itself implements default. And we saw that with that 0, 0. But let's say I don't want it to be that. Let's say for our velocities, everything starts moving horizontally to the right. So what would that be? For the X, that means we're moving at like 5.0. That's our default for that. But for the Y, the default of this is correct. We want this to be 0. So I'm going to leave that as it is. Now everything works, and what I can do is instead of this player location here, we can get, we'll create our entity, have it be a default. So let player equals entity default, and then we'll just debug the player. And we'll see here, our player has a location and a velocity, and there's that default value that was added in there. Which is, it can really be helpful. It's one of the few ways that you can set like what defaults are. Now, what we can't do, and something that is like highly requested, I can't have default values for methods, just structs like this. So if I try to just do impl velocity, and I try to have like a function new like this, I can't have something like, well, I want like an X and a Y, but I want them to come in and be able to override, but then I want to have a default value if they're not passed in. The way we'd have to manually implement a default for this would be like this. We'd have to say, our X is going to have to be an option with an F32. We're going to do the same thing for the Y. We're going to return that capital S self. And then we're going to have to do this entire like extract out of here. Okay, so let's then get our self here. So self with this. And then our X is going to be this X unwrap or, and let's do the default, which would be like 5. And then our Y is unwrap or default. And I think, is there an unwrap or default? Unwrap or default for this. And this is the way that you have to do a manual entry for this. So to use this, let's say we have a player is coming in with just the entity default. We're gonna have a let enemy. It's gonna be equal to entity new. And then we have to have like, yeah, so you have a none and a sum. Yeah, exactly like what this is. And then we'll have our enemy and player. Oh, that's a velocity under new. Right. That's oh yeah, that's gonna be a little bit harder for me to do because that's like a sub of the entity and I don't have a constructor for that. That's gonna be not fun. Musean, hello. You can use impl into option whatever to get more ergonomics. Oh really? Impl into. I don't think I've, are we gonna look into, do I have that? Oh man, it's just literally finding anything because it's the title of the thing. There's into, yeah, that's not helpful. Is that a trait? Oh, I don't even know. Do I? Do we even have from in here? Okay, I have a convert. Okay, I have an into and a from. I do have those. We're gonna get to them eventually. Wolf said you should probably be worried that you've got Windows back on a laptop and now it doesn't recognize any routers. Like you can't see any of them. Yeah, that doesn't sound optimal. That sounds pretty bad. Okay, so this is something that you can do, but using the into is probably even better. So let's just say, wait, this is the wrong one. This one. This allows us to manually have like manually override, like have default. Okay, have default values for what is passed in. However, it does look pretty terrible. We can use into trait to make it a bit nicer, and we'll be going into that a little bit better later. So let's come back to here and replace you. All right. Then we have our required methods. So in this case, there's only one method on here, default. So obviously this just returned the default value for whatever type this is associated with. So this will return the default value of whatever, I guess like struct. Now, I think we didn't check it. I want to see, can I implement default for an enum? So let's do an enum, sure, enum direction. There you go, Copilot. We're gonna have up, down, left, and right. There we go. Now, I don't think I can derive default for this because it doesn't know which one to do. We can try though. So we can derive, sure, debug, and default. Now it should yell at me and say, hey, I can't do this. You can only derive default for structs. So defaults can only be derived for structs automatically. Or I guess derived, yeah. But can I impl it for an enum? Let's find out. So I'm gonna do a impl default for direction, implement that default member, and so what we're gonna say is, sure, direction right is the way to go here. And this seems to work. So we can now into our location, into our entity, let's have like just our direction, right? So direction is a direction. And so we see that we're just going to get this entity default here. We're not going to even have an enemy. There we go. Let's run you. and we'll see direction is right. So we can definitely derive, can't derive it, but we can implement default for an enum. So we can create a like default struct, like a default state, for example. So return the default value of the struct or enum when derived. Every member must implement default. Otherwise, we can control and set default values for everything ourselves. All right. I think that's it for default. Yeah, and then we just get our implementers. And we can see how many of these things implement default. A ton of stuff. Okay, we've already looked at hash. Ops index. So index is used for indexing operations, like container index, in immutable contexts. If you have a bare function new on your type, then you should always provide a default impl that just delegates to it. That is correct. Oh yeah, that is absolutely correct. Let's do that really quickly. So in our entity here, we can impl. We can impl entity. So function, I guess it'd be a pub function new. So we have a bare new method here that doesn't take any arguments. Therefore, we should also create, manually implement the default trait for the struct and have it run the new method. And of course, the inverse is true. If the new method doesn't really do anything special, then it should just call the default method. So for example, here, in this case, we should just call the default method. So we're just going to do self default like that. And then now doing entity default or entity new is exactly the same thing. So we can just do that enemy equals entity new. And they are exactly the same. And if you have a manual new impl, then you can manually impl derive to call new. Yeah, exactly. So we impl entity, and let's now stop the default there. Impl default. Now, I think, can I get myself into trouble here? Can I do, okay. Are you gonna let me do this? Stack Overflow. So it is possible for us to create an infinite recursion here. It's not really recursion, right? It's just like they're calling each other over and over and over again. So at some point in time, we have to like decide what we're doing. Now, super unhappy there. Trait default. So at this point in time, we're like kind of very unhappy. We have this new here. We can't like this is a terrible idea. So infinite loop, recursive loop. Webcam. Uh-oh. What happened? Ah, it's falling backwards. Okay, how about that? Thank you for letting me know, Lego Logic. Also, hello. Okay, so wait. Infinite recursive loop here because we're calling the default method. Wait, no. Infinite recursive loop here because we are calling new, which calls default. Oh, sorry. What cam am I using? I'm using the Logitech 920 or 910. Doesn't say in the front of it. It's been a long time since I purchased it. I think it's the 920 or so. Okay, you had to reinstall the drivers. Well, I'm glad that worked. Okay, so it's called defaults. You know, one of them should actually like construct the thing. So we can't do like self new. So instead we have to do like self something. Now I can't do like self default because this is the default implementation for that. So instead we'll have to do it for each of these things. So let's see if I do self. We can do this. That works. Welcome to the internet age. Let's go back into, I lost it. Let's see, vault. There. All right, back to index. Used for indexing operations. Okay, so like container index and immutable context. Container index is actually syntactic sugar for container dot index index, but only when used as an immutable value. If mutable value is requested, index mute is used instead. This allows nice things such as let value equals to v index if the title if the type of value implements copy. I did not know that behind the scenes. It's really just doing index or index mute, depending upon what I'm going for. That's kind of cool. Oh, so I can implement it and do weird things for this. So hold on, before we like actually look into this, let's try index. So what exactly is this? This is a trait index. Okay, so let's create a they were showing an enum. I don't know if that makes sense. Let's do a struct. Let's do like the location struct for some silly reason. So we have a struct location, and we're gonna have our X and our Y. And so it's gonna be these two values. Just for simplicity's sake, let's also derive debug and default. So if I create this location, so let player location is equal to location default. Okay, so we get that there. Now let's say I want to index 0. For some reason, I want to get index of 0. And I want that to be this X, and index of 1 will be the Y. I don't know why I want to do that, but I want to do that. So we're going to impl ops index for location. Okay, so we have type output, and we're going to set that to be whatever we're going to be outputting. So in this case, it's going to be this I32. We have our function index. Index is going to take in an index, and then we're going to return whatever it is. So we can match the index. That sounds about right. So we can match the index. Okay, so if index is going to be a 0, then give us X. Otherwise, if it's 1, give us Y, and if it's anything else, panic invalid index. That sounds about right. That is true, Wolferzad. You could get an external card and use that. Like I remember back in the old days, that's pretty much what you had to do. So now if I want to debug, I can do player location of 0. That should work. Okay, what are you? Stop. Okay, what are you upset about? Missing generics for trait standard index. Okay, so expected 1 generic argument. Oh, so index is a generic. Oh, okay. So IDX. Now, oh, because I have to know exactly what it is. So hold on, it's not going to be. Can I say that I want you to be a U32, like a U size essentially? So then you are a U size. Can I do that? Yeah, that's okay. That's exactly what it is. Is how am I going to index this? So I could do things where I have an enum, for example, and I can use the enum as the indexer. So here, just pass in what I want, and I get this thing out of it. So that's an option. So let's try making something that's going to be a little bit, tiny bit more useful. Let's say instead of locations, let's reset this. I want to do, we have entities, and then we have like, yeah, we have an entity. So we have a struct entity. And then we're also gonna have a struct entities, like just all of the entities. So we know that the entity is gonna be a vector of entity. Okay. And let's say for some reason, like we have a type, right? So we're gonna have a enum entity type. So we have maybe player and enemy. So instruct entity. These are all gonna have to implement debug at least. Okay, so for this entity, I'm gonna want a like just my type is gonna be this entity type, and that's really it. That's all I really care about here. So when I create these, I want to say let our player equals an entity with the entity type of player, and then let enemy is the enemy. And then we can take a look at our player and enemy. And there we go. Okay, so super simple. Coding Garden fan, hello. Now let's imagine I want to index by entity type. And so I want to get a vector of the types that we got. So maybe we're gonna create entities here. So let's do a new. So impl on entities, pub function new. Entities. So we're gonna create multiple of them. So let's just do let our player is gonna have like an entity, my type player, and that's it. And then let's say we have like an enemy, which is an entity, enemy. Good. Let's do like a second entity too. So that enemy 2, still an enemy. Good. Now I want to return self. We're gonna do self, and then we're gonna have this entities, which is the vec with player, enemy, and enemy 2. Fine. Okay. Perfect. So I want to, instead of creating these here, we're just gonna say let entities is equal to entities new, and we'll debug all the entities. So this should do what we expect so far, but now I want to index by type, and it's just sort of like a query. So I'm gonna get back a vector of all of the types that we're expecting. So for entities, we're also gonna impl index of entity type for entities. Implement missing members. Okay, so type output is going to be equal to a vec of entity. So it already sort of knows what we want to do here. Our index is going to be this entity type. So we're going to, I guess, match on this, but I guess we don't really need to. So let's make sure that we can partial equal on this too. Partial equal. And then what we're gonna have to do is loop through each of these, the vector, and return a slice, essentially, of, well, I guess it's not gonna be a new vector. We're gonna return a slice. So a slice of entity. I don't want to just grab everything. We haven't gone through vector yet, so I don't remember if there's any good methods to like just grab a slice based upon a condition, like a filter. I don't know if filter would actually return what I expect it to. We can try collect and see what happens. Or we can just sort of build it out ourselves. So what do I want to do here? I want to search through for each thing. I don't know if this is going to be the easiest. Maybe what I want to do is a... Let's change this again. Let's do a vec of a reference to entity. That might make more sense. Now I can collect and do this. So we're going to do a self.entities, which we see in here. We need to filter through it, but to filter it, we need to get it into an iterator. It's not exactly what we want to do. So filter, we are going to take in the entity here, and I want to return that the entity dot my type, I guess is equal to the index. Yeah, that's true. Then collect it into this thing, which I don't know if I need to tell it what to collect into because we have this type here. But this should also work. So if I run that, index returns a reference, which won't work here. Oh, I need to return a reference to the index. Oh, because the vec won't live long enough. Got it. That's a problem. I see that now. I missed that reference. So it does need to be a slice. How do I... Can I get a slice from a vector? In like what I need here. And I can't like just sort of override this because that's the signature of the trait. So I can't really do that. Okay, so the vector won't work because it's going to have to be a reference to a vector with a reference. Vec as slice, but still won't live long enough. Yeah, okay, so I have to think about like what I would need to get in here, which is unfortunate. It's almost as if I do want to have like just an array with a reference to entity like that. You'll need to store that intermediate vector in a struct to outlive. To outlive the reference self call. So like a queried, yeah, but that seems not great. So if we do something like this, then I need a lifetime specifier. So like, oh, I can't do that there. Now I need lifetime specifiers everywhere. Entity is actually living elsewhere. So something like that. Oh, no, not there. I guess it's here. Wait, where do I put the other lifetime? Oh, it's not constrained by the predicates. Unconstrained. Oh, I have to constrain it. That's what. Don't even bother allocating the vector. Just return the iter filter from that get. Oh, okay. That could work. So let's do this and it'll yell at me for what it is. So we're not going to collect. We're going to return the filter, which returns a filter type. So this is going to be a filter with self and p, with p being whatever we're doing here, which is entity type. No, entity. Will that work? Oh, true generic arguments. We need entity. Oh, add missing generic argument. Can I just do that? Oh, I just need something in there. Using this still won't work. The return type needs to be borrowed for the remainder of the lifetime of the call, so manual getter function would be best bet. Okay, so I can't really do this nicely. Okay, so index trade is super limited. All right, I was hoping that I can like trick it, but I think our original one. Okay, let's just go back until we get our original, which is that what's it called? Did I put it over here? No, I did not. This one. This works, but the other ones don't. So index allows us to use the syntax on anything we want to get information. It's pretty limited, so we can't use it in more advanced situations like querying for a vector or array slice. Okay, associated types. We have this output, but it must be sized. So we have this output. The output must be is sized. So must be something that implements sized, that the compiler knows what the size is. Note that the method turns a ref to whatever this is set to. So vec to reference to t could be implemented via index, which is kind of what they do. So that does make sense, yeah. Index is mostly for getting one borrowed element out of something. That's a good thing to note too. Index is mostly used to get a single item out of like a collection of something. Okay, then we have our required methods. So we have index. Basically this just like does the thing to like get the contains the logic to take in a index and then return the single return a reference to a single object of that type, of the output type. And then this is allowed to panic. So it's expected that this method will panic in the case of an out of bounds error. All right, and that's it for that. All right, so everything is saved. We're good there. I'm gonna go ahead and bring the stream to a close today. It is almost 9:30. I've got to head off to work pretty soon. No stream tomorrow. I'm on my new schedule, so I'm gonna be doing Mondays, Wednesdays, and Thursdays for the foreseeable future, since I have work meetings on alternating Tuesdays and Fridays, and I just don't want to have to deal with other weirdness of like this week I'm on, this week I'm off. It's just going to be more consistent that way. Yes, and there is index mute. I think I have that set up. Yeah, that's the next one to sort of go into is index mute, which is really the exact same thing as index, except it allows us to get a mute there. So, and in fact, like that's a pattern that we see in a lot of stuff in Rust. But we'll be going over that next time, which is going to be Wednesday morning at 8 a.m. Mountain Time. So with that, thank you everybody for hanging around. Thank you, Musean, for the help, and I will see you all next time. Bye.